Hello, guys. Good day, and I greet you all. And thank you for joining my channel once again. I go by the name Yosin Emmanuel from GCTU Ghana Telecommunication Technology University from the Software Department. And in today's lecture, we are going to talk about programming with C++. So, without wasting much time, we dive into our objectives for the day. These are our objectives for the day. One, we need to understand the C++ program development. Introduction to C++, why we should learn C++, the difference between process and trends, learn the difference between C and C++, explore C++ programming in code blocks, learn the object-oriented concept of C++, learn the standard library components like input and output stream. So in today's lecture, that's what you need to learn. So in general, when we talk of C++, it was created by Bijan Strostrup in 1979, formerly called C with classes. C++ was coined by Rick Marcetti in 1983. It was commercially released in 1985. C++ evolved from C, so meaning the C++ language is a subset of the C language. In the mid-1998, ANS or ISO C++ language standards were approved. Why we should use C++? It is used in every computing system, so you should think of how come your computers or your systems came about. And you should know C++ is a high-level language for machine language and assembly language and everything. C++ deals in those stuff. So to program your system to work the way you want, you can never do that without leaving C++ behind. It's efficient, close to the machine programming, as I said earlier. It's used for programming machines, heavy-duty machines, and those stuff. System programming languages. C++ has object-oriented programming, meaning you can do those object-oriented programming like the programming of robotics and those stuff. With C++. C++ is a compiled language, meaning it entails different stuffs coming together. Universally usable model programs, meaning it's usable, like you can use it anywhere. Portable programs for various platforms, self-explanatory. And we move to object-oriented programming. Identify components called objects. Object-oriented programming, identify components are always called objects. Specify relevant data and specifies relevant data and possible operations to be performed on that data. Each object consists of data and operations on that data. So without wasting my time, we move on. Object-oriented programming. An object combines data and operations on the data into a single unit. An object combines data and operations on the data into a single unit. So it deals with combination of combination of data and operations of that same data into a single unit. Programming language that implements ODD, object-oriented design, is called an object-oriented programming, OOP language. Object-oriented programming. With object-oriented programming, you need to learn how to represent data in computer memory. This, you are going to learn how to program data or instruct the data with memory. Understand? How to manipulate data and how to implement operations. As I said, you need to know how you go by feeding the computer with data or instructing the computer to do certain things for you. Write algorithm and implement them in a programming language. So you are going to write an algorithm and implement them in programming language. So, self-explanatory, as I said earlier on. Object-oriented programming, data abstract. This is the creation of classes to describe objects. Data encapsulation for controlled access to data. Object data. Inheritance by creating derived classes, including multiple derived classes. Polymorphism. Greek for multiform. This is the implementation of instructions that can have varied effects during program execution. A C++ program. So in general view, this is the general concept of C++ program. As let's say from this is the general view of a C++ program. We have the hash include IO stream. That's our preprocessor. We have the using namespacing. You know this STD. Int main. Then you move to your open parenthesis. That's where you have your body. If we should talk of ATM or something, you have your body. Yeah. I should know without you closing this. This is a form of closing, return 0 to tell you need an output, to tell the system you need an output. So return something. If you don't put any return here, nothing is going to happen at the end. Then we go on to processing a C++ program. To execute a program written in a high-level language such as C++, as I already said, C++ is a high-level language. So to execute a program written in a high-level language such as a C++, use an editor to create a source program in C++. So you need an editor to create a source program in C++. So some of these editors are VS Code, that's the Visual Studio Codes, the C Lion, the code blocks, and what have you. In a C++ program, statements that begin with the symbol hash are called preprocess directives. That's what I said earlier. So when we move back here, we said what? Statements that begin with the symbol hash. So when you come here, you have hash include IO stream. So all this line here, that's what we term as preprocessor directives. Yes. We can have countless of that. You can have hash include CMAT, hash include vector, is a whole lot. So you need to know what you are doing. Then we move on. It says these statements are processed by a program called preprocessor. These statements are processed by a program called preprocessor. Yeah. Use the compiler to check the program obeys the rules. So there are certain rules that you must follow in programming. Translate into machine language, that's the object program. Then software development kits may be used to create a program. Linker. A linker combines object program with other programs provided by the SDK to create executable code. So linker combines object program with other programs provided by the SDK to create executable code. A loader. A loader loads executable program into main memory. A loader, it loads executable programs into main memory. That's it. The last step is to execute the program. The last step is to execute the program. C++ programming. So this is the structure. We have step one, the editor. That's talking of the software for it. We move to the preprocessors. That's the headers I said, and every statement that begins with a hash symbol is a preprocessor. So we have hash include iostream, hash include cmass, hash include vector, I said, and so on. We have the compiler. So the compiler is what compile what you inputted, run them, and if there are any errors, you get the feedback. If no errors, move to the linker. And with the linker, that's where we have certain things like the library. There are certain things you don't need to input everything long. So with your libraries, you can have your mathematical formulas. Yes, that's talking of. So to call the library, you need a preprocessor like the CMaths. That's it. So the CMaths is linked to the library source. You have your loaders and execution follows. Compiling and linking. Run code through compiler. So in compiling and linking, after typing everything and everything is true, you run your code through the compiler. The compiler generates errors. Look at code and remove errors. So if the compiler runs the codes and there are errors in your codes, look at the code, remove errors. Run the code again through compiler. Yes, so you need to do this until there are no errors in your code. In some cases, you may run it and have no codes at it, no errors at the beginning. Then that's when you are lucky. At certain points, you may have the code, you change it and still be having errors. That's when you need to have a critical look at what you've typed. If there are no syntax errors, compiler generates equivalent machine code. Linker links machine code with system resources. As I said, the linker links your codes with system resources like the steps in your library. So your common formulas and everything, they are in your system resources. So the system resources is talking of the library. We go to loader and executing. Once compiled and linked, loader can place program into main memory for execution. So the loader just loads your program into the main memory for execution. The final step is to execute the program. Then it executes and gives you the results. Compiler guarantees that the program follows the rules of the language. Compiler guarantees that the program follows the rules of the language. Does not guarantee that the program will run correctly. Compiler doesn't guarantee the program will run correctly. No. It guarantees that the program follows the rules of the language. That's it. It just guarantees you the program just follows. Make sure the program follows the rules. Doesn't guarantee the program is going to run correctly. Process is a program loaded into memory along with all the resources needed by the program. Each running instance of a program is a process. Each process runs independently. Trends. Trend is a unit of execution within a process. Multiple trends can be initiated from a single process. There are single-threaded processes and multi-threaded processes. Trends. So trends, you can just talk of like a path or something. Sure. Trends and processes in programming. The program starts out as a text file of programming code. The program is compiled or interpreted into binary form. The program is loaded into memory. Trends and processes in programming continuation. The program becomes one or more running processes. Processes are typically independent of one another. The trends exist as a subset of a program. Trends are communicated with each other more easily than processes can. Thank you all for joining today's class and catch up with you in my next tutorial. As I always say,